So what do I do first on number 1 here? Yeah, make some room. I like it. 11 ain't doing nothing for me, so let me get rid of it. So made some room here. So how do I, what are the 2 steps for completing the square?
Divide by 6 by 3.
Yeah, take negative 6 divided by 2.
Yeah, and then square it.
And then square it. If you maintain the sign, whatever the sign is, this will tell you. So negative 3 is what goes in here. And what do I have to add to both sides to make that happen? 9. And you can check. Sure enough, 3 times 3 is 9. Negative 3 is negative 6. Yeah. The process works because we developed it by looking at every possible thing that looks like this and what it would look like. And then we work backwards to develop a process that would always be able to make this become this. You know the process works. You can always check it, just make sure it's working. Equals 20.
Square both sides.
Yeah, the whole reason we did this is so I can just directly kill the square. Good. What can I do with this?
Factory.
Good.
So maybe 5 4.
Yeah. Square root of 4 is?
2.
Square root of 5 is? I don't know. So that should be as automatic as if you get 6 over 8 somewhere. You're like, immediately you're like, no, that's 3/4. So square root of 20, no, I can do something with 20. I can reduce that radical. I'm not done yet, by the way. Everybody thinks when I turn around I'm done.
Square root of 20? I mean...
What's up?
Yeah.
Well, you have to put square root of 20 at least. Because you square root both sides to kill that square. I really want this to make sense. What makes this problem ugly is that stupid term there. If that wasn't there, I could just solve for x, right? So that stupid term. So I want to kill that square somehow. This process lets me do that legally. It collects everything together in one big square that I can just kill. I can't kill that square. Because if I take a square root of this side, oh shit, it's gonna, oh shit, that ain't gonna work. So I need to collect it all. And what's the last step? Add 3. You normally stick that number in front. Just looks better. Are those like terms? That's probably why I boxed it off, right? It's kind of a giveaway. We're done. There's no like terms we can put together. If it was 3 plus or minus 2, don't box that off. Tell them what the answers are. Maybe. Okay. Now, hopefully you guys got the note on the handout. Every problem we've done has had a 1 here, and that's a necessity for completing the square to work. So the very first thing I need to do there is... Good, and how can I do that? Divide by 9. I don't have to factor it because I can just kill the 9 directly. It's in an equation. So I can divide everything by 9. So I get x squared. I know the minute fractions show up. Some of you think that you're doing it wrong, and some of you just go, let's hope he doesn't notice I didn't do that one. But just keep going. The process here actually makes it easy. You barely have to work with the fraction. You have to work with them a little bit. But I made this one really yummy because what are the steps to figure this out? I need to figure out how to make this look like this, and I have to figure out what to add to both sides to make that work. So what are the steps?
X plus minus 3 divided by 2.
Yeah, cut 3 in half. So I'm trying to complete the square. I'm trying to figure out what number goes here. So I cut that in half.
1.5.
And then I square it. So what's the 9/4? What's that for?
3 over 2.
It's what I add to both sides. And what goes in here is 3 over 2. Now you've got to remind yourself, we built this process off of observations. We know this process works. On one level it might feel like there's numbers coming out of nowhere, just throw them in there and just pray. But you can always, how do I know this is true? Because if I FOIL this, wouldn't I get 3 halves times 3 halves at the end? Isn't that 9/4? And what's 3 halves plus 3 halves? A whole 3. So you can check it, make sure it works. Make sure you put the right number in the right place. And what do I have to do over here? Common denominator? So he needs a 4. He needs a 9. So you get 20 plus 81. 101 over 36. Cool. And now I'm in a familiar place. I've done all this work so that I can just do what to both sides? Square root. That's the whole reason we do this work, is so that I get here, completed the square. I've got something squared now. I can square root it and kill it. Thank you. Always wait for somebody, the tone to become plus or minus, Jeff. Jeez. Good. And one last step. Yep. So you get x equals negative 3 halves plus or minus square root of 101 over 6. You could get an LCD between them, but there's no real good reason to. Because you couldn't even combine the tops anyway. Maybe. I like it. Some of you look confused but thoughtful. I like that. I can't make that face. But I really like the fact that some of you guys are showing me some kind of emotion. I love it. All right. Some kind of reaction. Okay. So that process will always work when you have something that's quadratic in nature. That's why the whole title of this chapter is all about quadratic stuff. So, I'm going to do something. It's in the book too, but I want to prove to you quadratic formula. All right, and then we're going to go back and actually do the first couple sections in the chapter. I'm trying to put the book the way it should have been, help the author out a little bit. So let me start off with a truly disgusting completing square problem. I'm going to do this one together. So there's 2 reasons I'm doing this. I want you to understand what to do when you have a fraction here already. We haven't seen that yet. We saw a whole number, and when I cut it in half, it became a fraction. But here I have a fraction to start with, and you can't even kill the fractions because you need a 1 here. So you can't multiply by the LCD because you need a 1 here. Too bad for you. I'm so understanding. So the first step, so I need to figure out what goes here, and the steps don't care. You just write them in a nicer way for yourself. What's the first step? I take half of the middle term. Why do I write it like that? Because the stupid thing's as a fraction, so I'm going to write 1/2 as a fraction. I'm not going to put 11 over 7 over 2 and make it complex and make it all freaky, and I'm going to make a mistake. Screw that shit. I'm going to write 1/2 of the fraction. And how do you do that? Yeah, negative 11 over 14. Bam. That's half of the... Right? That's the first thing I want you guys to realize. I think that's the only thing, right? Can't remember. I might need to finish this because it's really, really gross. What's the second step?
Square it.
Yeah, square this.
$1.96.
Cool. So that's what you would put where? I'll tell you where to put it.
Third term.
I like that. Right there. And that looks really gross, but I know exactly. The problem tells me how to factor it. How do I factor it? X. Bless you. Bless you.
Thank you.
You can do it. Minus 11 over 14. I mean, that's almost too nice to believe. I mean, that is horrendous. I don't have to give it any thought. That is how it's going to factor. That is too nice to believe. Cool. And then here, oh God, you have to get LCD between those. That's disgusting. Then you would take a square root, you plus or minus, who cares? All right, I made my point with that point. You're not going to get one that's gross. So we're going to do something that many of you guys would consider to be even more gross. We're going to do a problem with no numbers in it at all. Not even fractions. Just no numbers. Nah. So quadratic formula. How many guys know quadratic formula? Anybody? What's it for? I love that question. You know, like, we know it. We don't know what it's for.
Is it to find the vertex?
Sort of. That's one reason why I disagree with the way they order the book. They talk about vertex before they talk about this. Bless you. And the quadratic formula, it helps explain why the shortcut for vertex works, but it's not primarily what it's for. The quadratic formula is for solving equations that look like this. Now, we just solved an equation that looks like that, didn't we? Using completing the square. So, honestly, quadratic formula is a shortcut. The reason I do this is because sometimes it's longer than completing the square. But the quadratic formula is an alternate version of completing the square. It kind of completes the square first before I know these numbers. So we're going to do completing the square to this, right? When I say we, I mean I am, and you're just going to sit there and watch it happen. Right? It's in the book also, so try stay away somehow. Stay with me. Huh? No, it isn't. We're not even there yet. Again, the right order of this book is 11.3, 11.4, 11.1, 11.2. So we'll get it right. We'll get it right. So I know that this is A, B, and C, and I don't care. You know what the first step is. There's two answers I can take. For completing the square, there's two things I need to do. What was the first thing we did?
Take half and then square it.
No, I can't do that yet. Why? Good. I have to get the x squared with the 1 in front. So what do I definitely have to do then? Divide by 8. So we get x squared plus, there's still something in the wrong place. I need room here. So I need to move that over. Please don't even write this down. It's in the book if you want to see it written better. But I want you to see all the steps. I mean, what I've done so far is not difficult at all. Give me a break, right? I want a 1 here, so I divide by whatever's there. Okay, I did that. I don't even have to divide it because I can't. B divided by A is B divided by A. Okay. Then I need room. I need room. I know I need room. And then I do. Now you understand why I just did this freaky ass problem. Because what's the first step?
Multiply by half.
Yeah, take 1/2 of B over A, and I get
B over 2A.
B over 2A. For some of you guys, that should sound very familiar. The rest of you are like, keep going. What the hell?
Square that.
Square that.
So
Okay, out of there.
B squared over 4A squared.
Good. Okay, I like it. Really notice the steps are the same. Steps are the same. And I don't have to know ahead of time what the answer is going to be. I apply the steps and see what happens. I'm trying to figure out why. I understand this looks worse, but the steps are not worse at all. They're the same exact steps. So what goes here? B.
That one.
That one.
B squared over 4.
And now how does this factor?
X plus
B over 2A.
Yeah, so the first step tells you how it's going to factor, and the second step tells you what you have to add to make it factor like that. Always. Equals. Do these have LCD? Can I make them have an LCD? Can I put those together?
Yeah.
Yeah.
You'd have
What's?
to multiply by 4A.
Yeah, multiply by 4A. Is that cool?
What about A squared? A squared.
Well, now it's going to be A squared in.
Oh.
And he's a 4 and 1 more A. Okay, now that should definitely start to be looking familiar. So what do I have? I have x plus b over 2a squared equals 4ac, b squared minus 4ac over 4a squared. Now what do I do to both sides?
Square multiplication.
Is that a you recognize it?
Yeah, let's get it.
If you're paying attention, you should be able to follow every step I've taken. It's the same steps we took over every problem we just did. Just with A's and B's and C's, we got to start getting over the variable fear, right? Square root of both sides. So,
Plus minus.
okay, there you go. So you get x plus b over 2a equals plus or minus. Now what's the square root of the bottom?
2a.
And then I can just subtract this. So it's negative b, and they have the same denominator, don't they? So I'm a negative b plus or minus square root of b square root minus 4ac all over 2a, which is quadratic freaking formula. Right? Yes, sir.
How did you subtract the 2a without subtracting the b also?
What are you talking about? So subtract b over 2a.
Oh, okay. Okay.
They have LCD, so negative b on the top of that. Is that cool?
Yeah.
I don't know if any of you guys have ever seen that. Or did your teacher just say, this is the quadratic formula? You plug numbers into it, and shit happens. Deal with it. That's crap. You shouldn't take that shit. You should say, can you explain to me where that came from? And they say no. Then you say, let me go work on getting your ass fired. Thank you very much. Right? So we use the completing the square process that we know works for any of these. So of course it's going to work for the thing that represents all of them. So we just solved every quadratic function that ever existed. That's what we just did. That's all. That's all we just did. That's why it looks a little gross, because they had to do an infinite amount of work. Leave the for process alone. So what's this mean? I don't know. What was the problem we did? Let me see. Let's look at this problem here. Here, x squared minus 6x minus 11, right? That was the first problem on the handout. Cool? And somebody have what was the answer we got?
X equals 3 plus or minus 2 square root of 5.
Alright, so that's the answer we got from completing the square. This is completing the square, but it just says, instead of doing all this shit, just start here. It's solved for x. All I have to do is figure out what a, b, and c are. Sometimes that takes longer than the actual completing the square does. Some of you guys might not believe me, but there's an example on the other side of the paper where it's true. So what's a?
A is
1. Right, understood 1 there. B?
negative 6.
Negative 6. C?
Negative 1.
So just plug and shy. X equals negative 6's 6, negative b, give or take. B squared, 36 minus 4 times a,
1, negative
1, times c,
1,
negative 11. All over. Twice a. So you get 6, give or take, square root of 36 minus is plus 36 plus 44 is 80. Please don't do this, right? Why can't I just make that 3? Come on, Jeff.
Was it plus or minus?
Because it's plus minus. Division can't break into a plus or minus. Oh, damn it. But what part is this going to do something with?
Square the 8.
Yeah, what can I do with that? Let me cut to the chase. 80 is,
20 times 4.
but even better, it's 16 times 5. Right? Isn't that cool?
Yeah.
If you did 4 times 20, then 20 is 4 times 5. There's 2 4s, and there's the 2 4s right there.
6 plus or minus 4 rad 5.
And you can cut both of these in half, right? So you get, as long as you do both of them, it's legal. 3 plus or minus 2 rad freaking 5, right? Of course it's the same answer because I did the same thing. All right. So quadratic formula is just, the completing the square part is done. I just have to plug the numbers into the form of the answer. Completing the square is just do the completing the square process for every single problem, right? So they like to tout quadratic formula as being a shortcut. It isn't always. When the numbers are nice, I'm not going to do freaking quadratic formula. Screw that. I'm going to do completing square. It's quicker, to be honest. So if you look at the back of this, let me see if we talked about all these. Yeah, we talked about all of these. Sorry. Get excited about the weirdest things. So on the back of the completing the square handout, there's all the different methods for solving an equation that looks like this. Ax squared plus bx plus c. Factoring, obviously. That's the one we learned last semester, or whenever we reviewed it this semester. Square root principle, which was, if you look at it, we did those problems earlier. You guys with me? You're looking at this handout, or just you can just stare at me. It's fine. Completing the square, and then quadratic formula. So there's all the different steps. And notice, do you see example 3 and example 4? They deal with the exact same equation. Example 3 is much quicker than example 4. I don't know if you guys see that or agree with me, and it's true. So, quadratic formula is nice. It does cut things down for a lot of problems, but it's not always the best way to go, to be honest. Yes?
On the test, will you
I'll make it, I'll have, I'm going to ask for both methods, and there might be a problem where you could choose a method. You see, but I got to make sure you do both. Yeah. Or, all 4 of these methods, really. Yeah. Okay. So what we just did is we did 11.3, then 11.4, then 11.3. So let me just say, we just did 11.3 and 11.4. Now we're going to go back in time and see which one I want to do next. It depends on how the rest of the day goes. Let's see. Let's do, what kind of weirdness are they doing here? Yeah, let's just do this. I'm going to make sure that I talk about all the shit they talk about. I have no idea how my order is going to match with theirs. All right. So I've already said this word this semester, parabola. Right? Parabola. I've already said that word. And that's the shape of what? What takes the shape of a parabola? That is what the parabola is. What takes that shape?
X squared.
X squared kind of stuff. So the simplest parabola is this guy. And it does have the U shape, right? Because what do I get when I put a 0 in there? 0. So I'll make a little table of values. 0 is 0. Yay! What do I get when I put a 1 in there?
1.
What do I get when I put a negative 1 in there? 1. Good. And that's why it's got that U shape. It doesn't now absolute value looks like this. Because an absolute value wants to be linear because it's got a first power, but it has to turn because it can't be negative. This has a second power, so it's going to be curvy. Anything with a power that isn't 1 is going to curve somehow. It's not going to be straight. It's not going to have a constant slope. It's going to have a constantly changing slope somehow. Does everybody kind of understand what I mean by that? That's the whole point of that one section where it said, is this linear or not? Linear means it has a constant slope. Not linear means it has a slope that changes somewhere. Right? So this one has a slope that changes all the damn time. And what about 2 and negative 2? Those will both be 4. It's crazy. So then I have this here. What's the slope at 0? What do you think the slope at 0 is?
1.
What's the slope here? Is it positive or negative?
Negative.
Negative, because it's going down, right? Then what's the slope here? So what's the slope have to be here?
0.
0. Good. When you're at the bottom of a roller coaster, you are trying to go straight. And why don't you? Because then the other side of the rope happens to you, right? But you are going straight for that millisecond. Right then, you're going straight. And then it's like, oh shit, here we go. And the slope here is smaller than the slope here is smaller than the slope here. The slope just keeps getting bigger, bigger, bigger. Do you guys kind of see what I'm saying here? This is why linear functions are the only ones that have constant slopes. That's their definition. Anything that's not linear has a slope that's changing. Yes?
Will they revert back, or will they always just go up to a 90-degree angle?
Oh, so when you start in Math 176, you're going to do a lot more investigation of all these different polynomials. So you could have like an x to the 4th could look like x to the 4th is a controversial. It's what I call sometimes the butt graph. Well, because there's other names you can have for this thing. But that's what an x to the fourth looks like. It can have this little wobble in the middle, right? So the higher the degree, the more wobbles you can have. So x squared has one turning point. X to the fourth has possibly up to 3. So do you see the relationship? X to the fifth can have up to 4. I love it. There you go. See, look at that. That is the idea. It doesn't have to have that many, but it can have up to that many. Right? Anyway, that's beyond what we got to know for now. But that's a good question. So in 176, if you're going to take pre-calculus, you're going to study the hell out of higher order polynomials.
So we'll go up to 90?
No. Sorry. So your question, I didn't understand what your question. So hell no. If it went to a 90 degree, that would mean that some x's stop working. But all the x's have to have outputs. So it gets steeper and steeper, but it never goes straight up. Because I always have to be able to have bigger and bigger x's that have outputs.
The amount of
So if it went straight up, that would mean it stopped moving this way. That means these x's don't work.
sooner or later, it looks like it doesn't.
Yeah, exactly. It's going to look like it's straight up, but it's like 0.000001 off from being straight up. It can never be straight up. I like it. Good question. It's just really steep. Stupid steep at some point, but it's never going to be straight up.
Won't ever come back on it.
Never. I like it. Okay. But in general, this has the shape of this. It's going to be moved around. If I start adding stuff in, it's going to move it around. So what we're getting into now is how to figure out where does it move to based on what I see in the equation. So somebody help me out. What's kind of the most important point, in a way, in this graph?
0.
Yes, this point.
Center.
What's it called? Anybody know?
Center.
Vertex. The vertex of that bad boy. So there are like comets that have parabolic orbits. So that would represent the closest approach, maybe, or if the Earth was here, that's the closest it gets to the Earth. Is that vertex point? Now, of course, we're talking 3 dimensions now, but basically the idea is still the same. Maybe. You guys know about that probe that went up to Jupiter? Juno?
Yeah.
That's awesome.
5 years.
Huh?
Took like 5 years.
Yeah, it took forever to get over there. Of course it did. It's a little distance. But it has all these instruments on it. It's going to analyze Jupiter the most that's ever been done. It's look at all the gas clouds and stuff. Anyway, sorry. I like that it's called Juno. If you want to Google it and get that movie. Let's see. So the next thing I want to talk about. So the vertex here is 0, 0. Because when I plug a 0, I get a 0. But more importantly, it's the point where things start to have to go the other way so that it doesn't become negative. But help me out here. What if I had y equals x squared minus 1? The vertex will no longer be at 0, 0. Vertex is a point, yes, 0, negative 1, because that, all the outputs that are here, I'm going to do what with them? Take them down by 1. So the parabola normally looks like this. Normally looks like 0, 0, 2, 4. So it normally looks like this. This would take all the points down by 1, down by 1, down by 1. We get the idea, Jeff? So that's the new function there. So this is called graphing by transformations. The minus 1 is a really, really basic transformation to it. It just takes what it would have been without it and takes it down by 1. If I would have put a plus 2, it would have taken the parabola and moved it up 2. So now the vertex for this guy is at 0, negative 1. I like it. So obviously anything that looks like this, x squared plus b, for example. The vertex would be where? 0b. I like it. Because the plus out there, it only moves the y up and down. It takes the outputs and moves them by b. B can be negative or positive. So if it was minus 1, it would move all the outputs down 1. All right, so everybody kind of see that. I think this is the first time some of you guys have realized that a whole other way to graph things is just to graph the base function and then move it. That's a complete, instead of making a whole new table of values for this, I'm like, I already know all this shit. Let me just move those points.
So the change is gonna be y lines, not x's line.
Do you?
So y lines will go like x2 minus 1. Y line will go.
Oh yeah, the y part will
X
go
is
up or
the
down. So
X
now we
is
got
the
it,
same.
exactly, x will stay the same because x hasn't changed at all. In fact, do you see how I can put the 1 with the y? What makes this 0?
Negative.
Bam, right? Now watch. Keep that in mind. You know, like, I don't know if you know what bam means, Jeff. I don't know what that means. Watch this. So how do I move the x around? I have to put something in with the x. So y equals x squared, again, looks like this. Let's just cut to the chase. That's y equals x squared. So if I do this, now people are going to go in the wrong direction. I don't blame you. But the way you got to think about it is what makes that 0. What used to make it 0 is 0. Now what makes it 0? 1. And it moves it to the, holy shit, the opposite of what you would think. But remember what I just said. If it's with the letter, you think about the opposite. What makes it 0 is negative 1. Bam. What makes that 0 is 1. Bam. So every point is going to move over 1. Move over 1. Move over 1. That's where the new parabola is. Let's check it. If I plug a 2 in, I'm supposed to get a 1 out. 2 minus 1 is 1 squared.